Moving on to question 4 now, we have a question here on 3D vectors. So it's a pretty brief question, and what it's asking is, can we determine whether this line here, so we've got the line L with this equation, whether it intersects this plane pi at a single point, does it lie in pi, so lie on the plane, or is it parallel to pi without intersecting it? So 5 marks for this. So let's jump straight into it. Now there's a couple of ways you can actually do this. The easiest way, I think, is to consider the direction vectors. So first let's write the vector equation for L. So if I call it R, so R equals, well, my position vector will be the opposite here. So because it's x plus 2, my first one will be minus 2. This is minus 5, so that'll be 5. And this is minus 4, so that'll be 4. Okay. And then we need the direction vector, so lambda lots. Well, my direction vector is just simply the denominator of these fractions here. So it's 1, minus 1, and minus 3. And we don't change these, so it's just 1, minus 1, and 3. Sorry, minus 3. Okay. So now we've got these. That's my direction vector here. I've got this plane here, and this is my direction vector here. So that's my direction vector. So now, if I consider using the dot product for these two direction vectors, let's see what result we actually get for this, because this might help us prove something. So if I find the dot product, so I've got 1, minus 3, dotted with 1, minus 2, 1. So 1, minus 2, 1. Let's see what we get. So this is going to be equal to 1 times 1, 1 times 1, plus minus 1 times minus 2, plus minus 3 times 1, plus minus 3 times 1. Okay, 1 times 1 is 1. Minus 1 times minus 2 is 2, so that's 1 plus 2, plus minus 3 times 1, so that's minus 3. Okay, 1 plus 2 is 3, minus 3 off. We're going to get 0. Okay, so this is equal to 0. Now, if you calculate this dot product here for the two direction vectors, and your result is equal to 0, and don't forget this is a plane, what it means is that the line must be parallel to the plane. So the first thing we can say, therefore, is that the line is parallel to capital Pi. So my capital Pi is not very good, but there we go. So it's parallel to the plane. But now we need to consider whether it actually lies on the plane as well. So what we've got to consider here is a point on the line L, and then consider that point. We can then substitute this into the plane and see if it still lies on the plane. So the easiest point to consider for the line L, so if I call the point P, so looking at our equation here, minus 2, so we've got x plus 2, y minus 5, z minus 4. The easiest point is just to consider the origin, so 0, 0, 0. Well, for that, x must be minus 2, y must be 5, and z must be 4. Okay, so the point P I'm going to take will be minus 2, it'll be 5, and then 4. Okay, so again, use this point now. If we use our direction vector here, substituting this point in, what we should get, if it does lie on the plane, is minus 7. If it doesn't, then it doesn't lie on the plane. So, subbing this in now, I'm going to get 1 times minus 2, minus 2 times 5, and then 4 times 1. So if we do that, so subbing into the plane now. So that's going to be 1 times minus 2, plus 5 times minus 2, plus 5 times minus 2, and then finally 4 times 1. So let's just double check I've not made any mistakes. Yeah, that looks good. So that's going to give me 1 times minus 2, that's minus 2. 5 times minus 2 is minus 10, and then we've got plus 4. Well, minus 2 minus 10 is minus 12, plus 4, that's going to give me minus 8. So this clearly isn't equal to minus 7, right? So minus 8 is not equal to minus 7. Okay, so this would have been a contradiction if we'd have said minus 8 is equal to minus 7. So therefore P does not lie on the plane. So now the final comment we can make, so if it doesn't lie on the plane, but it's parallel, so what we can say therefore is that L is parallel. So it's parallel to pi, but it doesn't lie in the plane, but not in the plane. And there we have it. So it's quite a brief question. There's a much trickier 3D vectors question much later on in the paper. But there we go. That's question 4, fully complete.